So in this video, we are going to discuss optimistic locking, right? So this is a system design concept that is used in highly concurrent system. Okay. So what do I mean by high concurrent system? That means when a particular resource is being updated simultaneously or concurrently by multiple users, right? So that will lead to data inconsistency. Of course, I'll give you a demo, but there is a problem that we want to solve. Okay, and we are going to use optimistic locking for this, right? So what does this do? This solves data consistency challenges, right? And I learned this technique when I was working with one of the architects from Poland 2-3 years back. So I decided to share this information with you, right? So as I said, this is a concept that you can say it is part of system design concept, right? And this is used in high frequency and highly concurrent system, right? So what does this do? This ensures that updates are only applied if the data hasn't changed since it was last read. That means you can only update a data if you have the latest copy. If you have a stale data, it will not allow you to update, right? So how do we detect whether we have a stale data? Of course, these are the techniques that we are going to learn in the video, right? Then so what are the benefits of optimistic locking, right? So highly concurrency with minimal performance impact, right? And why we have minimal performance impact? Because we are not doing a thread lock or a database level lock, that is a row lock or a column lock, right? So of course it's lightweight, right? Because we are just doing validation, right? And what this will do? This will prevent overrides. This will prevent the loss of data integrity, right? And what this will do? Conflict resolution, right? So it will detect conflicts. So if I'm trying to update a data, is that data has already been updated? Do I have a latest copy or I have a stale copy, right? And we will try to gracefully handle it, right? We can tell the user, first you don't have the latest data, do a refresh, and then on that latest data you try to update, right? So what this video is about, of course, optimistic locking, but I'll show you 3 different techniques to achieve optimistic locking. Not one, not two, but 3 different techniques, right? Now why 3 different techniques? Of course, each technique has their own role. Some of them are simple to implement, but they are less secure. Others are highly secure, but of course security comes with performance overhead, right? So end of the day, you have to decide. One is not better than the other. It's your business need that decide what solution you have to implement, right? So if you are implementing a simple solution, right, and you know that all your users are, say for example, enterprise employees, and they are not going to misuse the system, so you can implement a relatively simple solution, right? But if security is your concern, you have to implement more secure solution. Of course, I'll show you the simple solution, the little complex solution, and highly secure solution, right? Of course, each of them have their own advantages and disadvantages, right? And at the end of the day, it's the business need that decides what we have to take, which approach we have to take, right? So let us quickly go to a demo. Of course, I'm going to use Postman and backend APIs to give the demo. The API in itself is not a complex API, it's just a CRUD operation. But how we are doing the update, what kind of validation we are going to use, this is what this video is all about, right? So let us quickly go to a demo and see what is the problem. Then I'll show you the code example and see how we will fix the problem, how we will design the solution in 3 different ways, right? So if you see here, I have a task API, right? So it will take title, description, and status. So first what I will do, I'll do a post request. That means I'll submit some data. Simple, right? So I have submitted the data, and what I get a ID, right? Now with this ID, I'll do a get call, right? So this is the data that I'm getting from the database, right? Now here, if you see update 1 and update 2, that means what I'm trying to do, I'm trying to mimic 2 different updates, right? So what I will do, I will take this ID and update the parents, right? Then what I will do, I will take the title, description, and status. I will take the title, description, and status, and this is the value that I want to update, right? Here and here, right? That means 2 different process or 2 different person, they have loaded the same data, right? Now what will happen? say first person, what he is doing, he is updating. So what is the description? Record new short for YouTube for SQL, right? So first person decide, no, it's not for SQL, but it's for JavaScript example, right? So what he will do, he will send the data, okay, and it has been updated, right? Now comes the second person. What second person has? He has the old data, right? It still says SQL, right? And what this guy is doing, this guy is marking it as completed, right? Now what is the problem here? The first person has already updated it to JavaScript, right? But this person still has the old copy, right? He has not refreshed the page, or two people have loaded the data at the same time. One person has already updated the data, right? Now this person has stale data, right? Now what he is doing, instead of in progress, he is marking it as complete, and he will send the information, right? Now what has happened? It is now SQL, right? So what has happened? The first person's update is lost, right? So if you get call, what will happen? It is completed, but with what information? With the old information that has been updated by the second process or the second user. So what has happened here? The first person's update is lost, right? So now what has essentially happened? Data is now in an inconsistent state, right? This is not what we want, right? We should always have data consistency, right? In this example, it might look simple, but assume big systems like where we are writing logs, where we have client information, where we have banking transactions, right? What will happen if two process, they update the data? One process has already updated, second process has the old copy and it's doing update, right? So what will happen in this scenario? We have data inconsistency, right? So this is not the state that we want our database to be in, right? We should always have consistent data, right? So this is the problem. And optimistic locking, we are going to use the technique to solve this problem. We will detect stale data, and then we'll tell the other user you don't have the latest data, right? So I'll show you three different techniques, and as always, all the code link that you will find in the description. If you want, you can check the code samples, right, that I'll be writing here, right? If you want, you can take that as a reference. And so far, if you are liking this video, give this video a thumbs up and consider subscribing to the channel, because this is the kind of video I bring on a regular basis, right? So if you think this channel is helpful, consider subscribing. Do give this video a thumbs up. And now let's get our hand dirty with some code. So let us first discuss the base project, right? So very simple API implementation, right? So what I have done, this is the package.json, right? I have a dev script that will run node1 with src index.js, right? And what dependency I have? .env to read the environment variables, express our API framework, and mongoose to talk to MongoDB, right? And of course, you will find the link of this starter code as well as all the solution in the description. So if you want, you can check that out. Otherwise, this is a very simple API. If you want, you can also implement on your own, right? Then I have two environment variables. One is the port, it will run on port 8000, and Mongo URI, right? So it is running on localhost and port, and this is the database name, right? Then what I have, get ignore, so I am putting node modules here. Then let us check the task schema, right? What I have here, title, right? Type string required true, description type string, and status type is string. And this is interesting, this is enum type. What do I mean by enum type? That means this status can have value either pending, in progress, or completed, right? And by default it will be pending if I don't pass anything, right? Then what I'm doing, I'm exporting it as a mongoose model, right? Then task route, okay? So this is a simple router implementation, right? So I have router.get, okay? So what this will do, this will get me all the tasks. And I have a get with ID, right? So whatever MongoDB ID I will send, it will find that task and it will send me. Otherwise, if there is no such task, it will throw 404 error, right? Then post simple implementation, right? So I'll create a new task from the request body and I will save that one and I'll send the response, right? Simple. And then put, so it will take the ID what this will do, this will find by ID and update. What will be the ID? That ID that I'll get from the ID that I'll get from request params, right? What this will update? Whatever I'm sending in the request body. And what is this new true? So what this flag will do, this will return the new updated data, right? Whatever is coming in this request body, right? If I don't pass this, it will give me the old data. Then it will return the response, right? Then delete, right? Simple implementation. So it will take the ID, and based on that ID, what this will do, find by ID and delete, right? And if it doesn't find the task, it will return an error message. If it successfully deletes, what this will do, it will return a 200 success, and it will return the deleted task if at all it is needed. Ideally, I should send 204 no content, right? But anyways, this is fine. We are not going to use delete method in this example, but just for the sake of completeness, I have added all the CRUD operation. Okay, then index. So I have all the three import express.env and mongoose. Then what I'm doing, .env.config, so that I can read the .env values, right? Then creating the express app. Then what I'm doing, I'm attaching this middleware express.json so that I can read the body information, right? Then app.use/task, the task router, right? Whatever I discussed here, right? So it is attached at /task path, right? Then what I have here, I have a IFI, immediately invoked function execution, right? Inside this, I have a async function. What it is doing, it has a try catch block. Okay, in try block, what I'm doing, I'm trying to connect to the MongoDB. And how I'm getting the connection? From the process.env.mongo URI, right? Then this will do a simple log. Then it will read the port. Then it will app.listen on this port, and it will give this error message, right? And for if any reason, if it fails, it will say fail to connect to DB. It will print the error. And what will happen? Process.exit with any non-zero value. So there is no point in running this server, right? If I am not able to connect to a database, or if there is any problem, right? So it will exit non-zero value, right? And if you see the package.json, I have the dev script, right? So I'm running npm run dev, and it is running. It is successfully connected to DB, and server is running on port 8000, right? So this is the base setup, right? So this much I have already done, because there is no point in explaining this again and again, right? Because in many videos I have shown you, even in my express course I have shown you. If you have not seen, I'll give the link in the description. If you want, you can watch that course, right? So a very basic express setup, right? And on this setup, I have given you the demo, right? So here on the task route, on this put method, right, there was the problem. So it is not doing any validation, right? So it will simply taking whatever data we are receiving, and it is updating it, right? So this will lead to inconsistent data, right? So let us first try to solve the problem. And now I am going to show you the simplest approach, right? So what is the simplest approach? So if you see here, when I do a get call, I get a __v from MongoDB, right? That means every time I insert a document to a collection, by default, each of the document have a version, that is __v, right? And it stays 0, right? So what I am planning to do is, I am going to use this version to detect whether you have latest data or not, right? A very simple implementation. If you don't have the latest data, it will not allow you to update. Okay, so I'll show you the database. So if you see this MongoDB compass, right? So of course it will have a ID, a title, a description, a status, and what it has this __v, right? So let us try to use this one to solve our concurrency problem, right? So we are going to use this __v, right? So when we are calling a put method, right, here along with the necessary data, that is title, description, and status in our case, we will also send the __v, okay, and whatever version we get from the get request, that we have to pass, right? So let us first do this one. So what I will do, I will add it. Of course, we'll have another demo after we are done with the code. Let me add it, right? So this is what I mean. So when the client does a get call, it will get a version. When you are trying to update, you have to send the version as well, right? So let us implement that. So here in this put method, what I will do, see, anyways, I'm getting the ID from the parents, right? So what I can say, const ID equals to request dot parents, right? Simple. Then const body equals to request dot body. So what this body will have, this will have our data that we want to update as well as the version. So can I spread this into two parts, right? So one can be my underscore v, and another is what I can say, updated data, right? Now what will happen, we have the underscore v and the data that we want to update, right? So with this ID, let me first check if any record or any document with this ID exists or not, right? So where I am doing this, can I borrow this line, right? So what I will do, I will do this. Okay, what I'm trying to do, I am taking this ID from the params and I'm trying to find by ID. So if this ID doesn't even exist, then there is no point in doing any validation, right? So I'm first doing get by ID, and if it doesn't find this particular task with this ID, it will throw the error, right? So if this doesn't happen, then we will proceed further, right? So what we will do, let us create the updated task with incremented version, right? So what do I mean by that? So I will say const updated data with incremented version equals to, okay, what I can do, I can say updated data and underscore v equals to underscore v plus 1. So this is the data that I will eventually update, right? Because from the client side, what we are getting the old version, right? So what we have to do, with every update, we have to increment the version, right? Then, so this is the data that we want to update. Now the question comes, how we want to find the record and then do an update, right? That is the interesting question. So here I am using find by ID. Instead of this, I'm going to say find one and update, right? So what is the difference? Find by ID will only take ID as the parameter. Find one will take multiple values, and based on that it will try to find. Okay, so how we want to find? Of course we want to find that matches the underscore ID from the ID that we are getting from the params. So this is the first condition. This underscore ID should match the ID. What else it should match? It should match the underscore v from what? From this v, because this is the old version and this old version exists in the database, right? So we have to find with this old version, right? So if we are able to find anything, we will update this updated data with incremented version. So this is the updated data that we want to send. And then I'm saying new to true. That means it will return me the new updated data, not the old data, right? Then what if this updated task is null or undefined? Okay, so this ID match will anyways pass because I have already done the validation. So if this ID doesn't exist, it will anyways, it would have returned from here. Now what could be the reason for this condition to come true? That means when this updated task is null or undefined, when the version doesn't match, right? That means this scenario, ID has already matched from here, otherwise it would have returned it from here itself. The version did not match, right? So in this case, what we will say, what error or what the status code will say, 409, that is conflict. That means what I will say in the message, I will update this message as, instead of task not found, what I can say, you do not have the latest data, please refresh before updating, right? And what we'll say, conflict, right? That means the version you are sending doesn't match the version that is currently available in the database, right? So let us see. So when somebody will with version 0, they will do an update. What will happen in the database? Instead of version 0, will increment the version to 1, right? When the other person comes with version 0, what that means, he has a version 0, but in database we already have version 1. So will this allow to do the update? No. So this will gracefully tell the user that you don't have the latest data. Why? Because the version that you are trying to send has been incremented in the database, right? So let us check that flow. So what I will do, I'll delete the old data from the database, right? In the other screen I have already deleted, right? Now I'll come to Postman and I will send the new data, right? So what has happened? A new ID has been generated, right? So what I will do, I will do a get call on this new ID, right? So of course the example is same, right? Here the SQL example will take and we'll try to change it to JavaScript, and in another screen we'll try to change it to completed, right? So this is what you get when you load the data. So what I will do, I will take this ID and update the params in the put request in both the tasks, right? So what I will do, I will take this title, description and status, and importantly version also I have to take this time to do the update, right? And similarly here also I will paste the version 0. Okay, now what will happen, we'll do the same thing now. So this first person is trying to update it to JavaScript, right? And what he will do, he will save it, right? Now if you see, the new data that we have is JavaScript and the version is now 1, right? So we'll confirm if we do a get call, right? So it says JavaScript instead of SQL and it says version 1, right? And if you check the database also, I'll do a refresh. So you see it has JavaScript and it is version 1, right? Then the other person doesn't have the latest data, right? So what he is trying to do, he is trying to mark it as completed, right? But what version he has? Version he has 0, right? So now this person is trying to update. Now what has happened? So if you see the status here, 409 conflict, and what message? You do not have the latest data. Please refresh before updating. So essentially what we have done, we have prevented stale data from being updated, right? So what this person will do, this person will refresh the page. That means he will do a get call, right? Now this person will realize, oh okay, so it has been updated to JavaScript. Okay, then he will mark it as completed, right? Now he will send the request and he will update. Now we don't have the data inconsistency, we have the JavaScript which has been marked as completed, right? And what will happen in the database, what version we will have now? We'll have version 2, right? So I'll show you in the database. So I'll do a refresh. So if you see, it is marked as completed and with version 2. So what we have done, we have essentially prevented the data integrity loss, right? So if the person doesn't have the latest data, it will immediately flag out. So simplest approach, neat approach, clean approach, easy to understand, fast. But what is the problem with this one? The biggest problem is these are numbers, right? 1 2 3 4. If there is a malicious user, what he can do, he can easily try to guess. So say for example, he will get the error that you don't have the latest data. So what he will do, he will manually from the client side, he can increment the version and do an update. Say for example, the latest version is say for example 14 now. He can do a brute force, right? 1 2 3 4, at some point he'll be able to update the data, right? It might not happen, right? And it might happen, right? There could be a malicious user. I cannot keep my code based on the goodwill of the end user, right? I have to write code assuming that good user is a bad person, right? It's not always true, but that's how I have to design my code, right? So version 1 2 3 4, it's very easy to guess, right? So somebody can do a brute force, keep on incrementing the version, and at some point he can update with malicious data, right? So this is a simple solution. Of course, based on your business need, if you think you don't have that kind of malicious user, it is going to be used by internal enterprise employees, right? Depending on what use case you are trying to solve, this is the easy solution, and if you want, you can go with this, right? But I have to show you different solutions, right? And there are potential security concerns with this one, right? It might happen, it might not happen, right? So I'll show you another approach. in which we are not going to use version, we are going to use a different approach, so that the brute force attack will not be possible, right? Of course, if you want, you can do a rate limiting, but again, if the user is just -1 version, right, he can easily do an update by just incrementing one version, right? So we'll try to find a more secure approach, right? So if you want, you will have this copy of the code as well. Then what I will do, I'll revert to the original state in which we had the problem, and we will devise another solution, right? So let me quickly increment that, and I will meet you after I have reverted all the changes, right? So now I have reverted the solution one, right? And in the code link that you will find in the description, you will have the solution one as well, right? We'll have solution one, solution two, and solution three along with the problem, right? In which we don't have any solution, the starter code, right? Everything you'll find in the description. You can check that out, right? Now I have reverted it back to the old state, right? Now here we have the problem, and if you check the schema, we have title, description, and status, right? And the underscore v, the Mongo engine that it used to give, right? So now we are not going to rely on that. So what we will do, we'll add our own version, right? So I'll say version, okay? And what this will be type, of course, this will be of type string, right? So this is the first change. Now we are not going to rely on the Mongo engines underscore v. Will have our own version, and this version will be randomly generated by the crypto module, right? Okay, so first change in the post data, when I'm getting the task, right? So if you check the postman here, what I'm sending, the business data, right? Title, description, and status, which is this title, description, and status. Now coming to version, what I will do, I will add my own version. Okay, task dot version equals to what? Okay, so what we will do, I will import, okay, import crypto from the crypto module that is built into Node.js, right? Now I will use this crypto to generate a random UUID, okay, random UUID. Okay. So that means every time I post a data, right, what this will do, this will generate a version, right? This version is randomly and uniquely generated, right? So this version now we are going to use to do our validation, right? So if you go to a get call, and I will take this ID now, and I will use this ID to do the get call, right? So now we have a unique version, and of course we can ignore this one for now. There are techniques in which we can prevent this from coming to the client, but we'll check that one later, not important. What is important here is this version, right? So we have a unique version. So in this update task, or in this put request, we will not use this underscore v, but rather we are going to use this version, right? So let us check that flow. So I'll come to put method, and here what I will do, const, I'll say version, and I'll spread the updated data from request dot body. So this flow we have already seen earlier. We are using underscore v, right? And can I extract the ID also? So I'll say const ID equals to request dot parents. Simple. And we will add the same validation here that we have previously added. So we'll first use the ID to find the task. Okay, if the ID doesn't exist, we will immediately throw error from here itself, right? There is no need to do any validation, right? Great. Now what we will do, we will create the updated task with the new version, right? Const updated task with new version. Okay, so how this will be, this will be updated data. Which data? This one that we are getting from the body. And version, what will be the version? Version will be crypto.random UUID. So that means when we are storing data, that means we are creating a new instance in the post call, we are using a version, that is we are getting random crypto UUID. Every time an update happens, we will change the version to a new random UUID, right? That means every time we do an update, we'll get a new version, and this is unique version, right? So it cannot be forced, right? And here also what we will do, instead of find by ID, we'll say find one and update. Okay, how this find one will work? So here we are going to use two different parameters. One is the ID, of course, and one is the version, right? So I will say underscore ID to ID and version to what? To this version that we are getting from the params, right? So if both of these matches, that task only we will update. Update with what? Update with this new version, right? So I will add it here, and of course new will be true, right? And if we don't have the updated task, that means the version mismatch has happened, right? So what we will do, we'll change the error message, right? So let me quickly copy it so that you don't have to see me typing it again and again, right? So what will happen if updated task, not updated task, then again that means there is a conflict, right? Why? Because obviously version did not match, right? If ID would not have matched, then it would have thrown the error out from here, right? Task not found. So if the control is coming here, not updated task, that means for sure you don't have the latest UUID, right? So let us test this flow. Let us see if there are any errors. We'll try to simulate the same scenario again. So what I will do, in the background, I'll delete the old task, right? In the other screen, I have deleted the old task, right? So if you now see task not found, right? So we will create a new task, right? So a new task is created with new ID and new version. So what I will do, I'll take this ID and I'll do a get call, right? So we'll get the title, description, status, and the version that we want, right? Then I want to update, right? So first what I'll do, I'll go to both the task and update the param, right? Otherwise it will throw parameter not found error, right? Task not found error. Then if I have to do an update, what I have to send? The regular update data, the business data, as well as the version, right? So I will send it here and I will paste it here, right? That means to client, they have loaded this data now, right? And I will remove this comma from here. This is not needed. This will throw error, right? Great. So now I have this. So here title, description, and status. So same thing I will do. I will first update it to JavaScript from SQL, right? And what I will do, I will send it, right? So I'll get a different version, right? That means version has been updated, right? So if I do a get call, it says CAF4 something and it says SQL, right? I'll send a fresh request. It says JavaScript and different ID 4240 something, right? Then the other person, right? He has the old data, right? He doesn't have the latest data. So I'll mark it as completed. And what he's sending the old version, right? So I'll send it. Now what has happened? 409 conflict. Same thing, right? You don't have the data. Now what safety we get? Somebody cannot forge this information, right? If it was a number, they can increment it and at some point it will work, right? Now can they generate this version? No, right? Very difficult. Of course brute force can be done, but it's very random and it's very difficult to have a collision, right? So this will prevent the brute force attack because this is very difficult to forge, right? So now we have little bit of security, right? Great. So we have some solution now and it is working perfectly fine, and if you want you can use this solution also. But do you see a problem with this? Just think for some time. There is a very big security concern. Okay, think about this and write it in the comment box. Let me see if you are able to guess it right. Of course I'll tell you the solution, but just think about this. Okay, how I can potentially misuse this, right? Of course when we are writing backend code, we cannot rely on the goodwill of the user. We have to always make our application secure. That is the base rule, right? So this will work, right? And if you think the product you are writing or the audience that you are targeting with your app, if you think they are not malicious user, then this will work. Even the old version with 1 and 2 and 3, that will also work, right? But I'll always assume that the user is a bad agent, right? And based on that I will write my code, right? So what is the problem with this one? See, now what I will do, I will do a fresh get call and I will take this new data with the new ID, right? That means both of the agent or both of the process or both of the person, now they have the same data, right? Now assume that this first person is a malicious user, right? So what will happen? The second person is genuinely trying to update something. Okay, so what he's saying instead of JavaScript, he's saying TypeScript, right? He's trying to update. The other person, what he will do, he will not do any update, but he will just simply send the data, false update. He didn't change anything, right? The data is as it is, right? Data is as it is. But what he has done a false update, right? Now the other person who is a genuine user, now he is trying to send the data. Nothing has technically changed, right? So even if this person does a override, there is no harm because this person doesn't change anything. The data is still in the same state as this one, right? And he's trying to update it with TypeScript. But can he do that? No, right? Because this guy did a false update. And every time we send a put request, it will update the version, right? So if I am a genuine user and if I am trying to update some data, a malicious user, what he can do, he can load the same data and do a false update. It will immediately change the version. Now I, the genuine user, cannot update the data. Why? Because I have the old version, right? So even if the other person doesn't change anything, will still update the version, right? And I can prevent a genuine user from submitting the data, right? You have to always think in this crazy way, right? Because this is absolutely possible, right? It's a separate question whether with your audience it is possible or not, but it's a possibility, right? I can keep on doing a false update, and genuine people who actually want to update the data, they cannot update. They have to keep on refreshing, and in the meantime I'm just simply doing false update. It will keep on incrementing the number. So what do we need? We need to not rely on version, but we have to see the data. Has anything actually changed in the data? If it has changed, even if a full stop has been added, we should be able to detect it, right? And we should tell the other user that you don't have the latest data. But if somebody is doing false update, we should not increment the version or our logic, right? So we have to find a solution to check at the granular level if anything has been actually updated or not, and based on that we will allow the other user to update or not. If anything has actually changed in the business data, right? I don't want to do somebody doing false update, right? Even if they are doing false update, we should be able to detect that nothing has actually changed, and we should allow the other user to update, right? So that is a solution that we are going to check. So this will be the third solution. This is the solution that is highly secure, but always security comes at the cost of performance. So you have to decide what kind of solution you want to do based on your target audience, right? I am giving you all the tools. So I'll revert everything. I'll put the code back to the original state in which we have the problem, and we'll try to find another solution, right? Of course, this solution works based on your audience. You can use this, but I'll show you even more secure approach, right? So that somebody cannot misuse the system, right? So I'll quickly revert and I'll meet you on the other side. Okay, great. So now I have reverted the solution, that is versioning, and now I have the starter code again, right? Now we will start implementing a better secure solution, right? Now if you see the postman, we are sending the version, either the random UID or the 0, 1, 2, like that in the request body itself, right? Do we have a better approach to send the version? So we do have a better approach that is called as an e tag, right? So let me bring you the Mozilla documentation and we will see what is this e tag, right? And of course we are going to use e tag because this is something part of the HTTP standard, right? So of course we should always write the standard procedures and that standard code, right, that adheres to the HTTP standard, that adheres to the REST API standards, right? So we have something called as e tag, right? So let us see what is this e tag. So an HTTP e tag or the entity tag is an identifier for a specific version of a resource. We are also trying to do something similar, right? What we are trying to do, we are trying to version our resources so that if we detect a change in the version, we will not allow it for an update, right? But if you see what it is used for, it is used for caching and saving some bandwidth, right? Also, it says e tag helps to prevent simultaneous update of a resource from overwriting each other. This is exactly what we are trying to do, right? So why not we use e tag, right? So this will be a efficient solution in terms of adhering to HTTP standard and REST standards, right? So it clearly says E-tag helps to prevent simultaneous update of a resource. This is exactly what we want to do, right? So it says E-tag and we have to send some data in the E-tag. Based on that E-tag, it will do the validation. How? So see, for example, this is the version, right? Similar to what we are doing. So they are saying E-tag, right? Now, when saving changes to a wiki, they are just giving an example, right? So when we are saving a change, that means a put call, what we will do, we'll send this header if match, right? So in the get call, we will have a E tag in our header when we are sending a put request. That means when trying to save a change, put request, right? What we will do, we will say if match in this header. Instead of sending it in the body, we'll send as a header with the title if match, and we will send our version or whatever the new data that we are going to generate, right? If the hashes doesn't match, of course we are going to use a hash, right? That is the solution that I will be showing you, right? It means the document has been edited in between, right? That is the solution we are trying to see, right? It should not have been edited in between, and a 412 precondition failed error is thrown, right? So this is what we are going to use, right? Of course, if non-match, and there are other headers, right? So I'll give the link to this particular Mozilla documentation in the description. If you want, you can read more about this. But what essentially we are going to use, we are going to use E tag, and we are going to use the if match header, right? This will adhere to the HTTP and REST standard, right? Now, I said hash, right? So let us discuss hashing. So what is hashing? Hashing is a one-way function, right? And the advantage of hashing is you cannot, of course, get the data back, but the thing is, if you give the same input, it will always give you the same output, right? So what we can do with our data, we can generate a hash, and that hash you can send, right? When somebody is trying to update, they will send us the hash along with the updated data, right? Now we already have data in our database with which we have generated the hash. We will regenerate the hash, right? If both the hash will match, that means it's a genuine client and he's trying to update and nothing has changed in between. If something has changed in between, when we try to regenerate the hash, of course both the hash will fail, right? So we can immediately flag out it as a conflict. Now what will happen? If genuinely data has been updated, it will generate a new hash and our hash validation will fail. But if somebody is doing false update, that means no genuine update has happened in the DB. Are we going to generate different hash? No, right? We'll always going to generate the same hash, because with false update, the actual state of the database or the document has not changed, right? So with same input, it will always result in the same output, right? So let us quickly implement the hashing and see how we can use that to solve our problem, right? So what we will do now, for hashing, we need what? We need salt, right? That's how we can uniquely always generate a new salt, new hash, even if we have the same data, right? See, there are counting number of algorithms with which you can generate the hash, with which we can generate a hash, right? And client anyways has the data, right? So what they can do, they can use different algorithms and use this data to generate the hash. So in order for us to prevent the client from generating forced hash, what we have to do, we have to generate a salt, right? And where we will store the salt? Let us store the salt in the database itself at the document level, right? So somebody cannot forge it now, because data anyways we are going to send it to the client, and we are going to use some algorithm. If we don't use a salt, it will be very easy to replicate the hash, right? So what we will do, we'll generate a salt, right? So I will say salt. So this will be our unique factor, right? So it will be of type string, right? So a salt will be added every time. How it will be added? It will be added in the post method, right? So if I see the post method, what we will do here, every time a task comes, I will say task. Earlier what we used to do, we used to say version, right? Now what we will say, we will say salt equals to what? Let me import the crypto module, import crypto from the Node.js crypto module, right? Then salt equals to crypto dot random bytes. Okay, how many bytes? 16 bytes. Then to string in hex format, right? Now what will happen? Every time a database is added, every time a document is added, it will generate a unique salt for this one, right? So let us check that one. So what I will do, I will clean the database once. I'll delete in the other screen, right? Now what I will do, I will come to Postman and I'll add a new task, right? Great. So we are getting title, description, status, ID, and we are getting salt as well, right? This is not something that I should send it to the client, right? Because then people can start misusing this one, right? This should uniquely sit in our server, in our database, right? So what is the solution for this one? I'll come to the post, and here I have the saved task, right? Now what I can do, I can say const. Also I was saying that this underscore v is not needed anymore, right? So what we don't need this salt, and we don't need this underscore v, right? So let us remove that one, right? So what I can do, I can spread underscore v and salt, and I can say rest of data equals to saved task, right? Then what I should send, I should send the rest of the data, right? But there is one problem with this one. I'll tell you. Let me load the data. If you see here, we are getting some different data, right? So this is actually the MongoDB schema, right? This is not what we want. So what I will do, this await save task, okay, I'll convert it to object, right? So I'm converting it to plain JavaScript object. Then from there, what I'm doing, I'm spreading out, or I'm removing underscore v underscore salt and the rest of the business data, right? And now I'm returning rest of the data, right? So I will send this one again. Now if you see title, description, status, and ID, right? This is all information that client needs, but it doesn't have version. Client doesn't need that, and it doesn't have salt because anyways client doesn't need that, right? Great. So we have this implemented where we are able to generate salt in our database, right? Now when we are doing a get call, let us use this salt, generate a hash and add it to the request in the header as e tag, right? So I'll come to this get request, right? Now we have the ID, right? And we will find the task, and if this task doesn't exist, we'll throw the error, right? Now I have the task. This is coming from the database, right? So in the database, we'll also have the underscore v and the salt, right? So I'll use the same tactics from here to remove the salt and the underscore v, because to generate the hash, I am going to only use the business data, right? Not the salt or underscore version, right? So with the business data only, I'll try to generate the salt. And again, here also what we were doing, to object, right? Otherwise we'll get the MongoDB schema object. Here find by ID, what it gives us a lean method. With this lean method, it will do the same thing what to object was doing. It will give us the plain JavaScript object, right? So once we get the plain JavaScript object, we'll see if it exists, we'll throw out the error. If it doesn't exist, what we will do, we'll take the business data or the rest of the data and salt and version separate, right? Then what I can say, const hash equals to crypto dot, okay, create hash, okay, and it will take the algorithm. So I'll say SHA 256, okay, and it will take the salt, right? So with what salt it will generate the hash, right? So what I'll do a little bit of indentation, okay. Then what this will do, this will update what, the data, right? We have to send the data also, right? This is the algorithm, this is the salt, then data. So we'll send data in json.stringify. What data we will send? We'll send the rest of the data or the business data, right? And we'll say digest to hex. So now we have a hash with us, right? Then what we will do, we will say res dot header. What header? E tag, right? E tag. And what value we will send? We'll send the hash. And here what we will send, we will not send the task, but we'll send the rest of the data. Why? Because task will have the __ v and the salt, right? We don't want to expose that, right? So what I will do, I will come to the task, and this is the latest task, right? So I'll take the ID and do a get call, right? So I'll send it, and something is broken, right? So let us see what is the problem. Saved task is not defined, right? So what is this saved task? Of course I have copied it from here, this line, right? So saved task. So instead what I should use this task, right? The task that I got from the find by ID, right? So now again server is running. Let us try this flow again. So I'll do a get call, right? So this time I get ID, title, description, status. But where is the hash? Where is the hash, right? So if I have to find the hash, where I have to check, this is body, right? So I have to go to headers, and in the header, if you see, this is the hash that has been generated, right? So your body is now clean, and now we are following the proper HTTP standard, right? Great. So now we have hash. We are generating a salt in the post call, and we are generating a hash in the get call, right? Now we have to do validation in the put call, right? Let us quickly do that. So I'll bring the VS Code, and I will come to this put request, right? Now what I will do here, so I will first extract out the ID, right? So const ID, from where I will get, from the request dot parents, right? And what I can do, then what I have to do, I'll take this flow, okay? So I'll find the task, and if this task doesn't exist, I'll immediately throw error, right? Great. Now what I have to do, I have to generate the hash again from what? From the data that we find from the database, right? And then we will compare it with the data that has been sent in the put request. So essentially I'll copy the same thing, right? I'll explain it again. So this is the hash that I'm generating again, right? Which is the same flow that I am doing in the get call. In the get call, what I'm doing, by ID, I'm finding the task. From that task, I'm removing the version and salt, and I'm having the business data. With that business data, I'm creating the hash and sending it, right? I have to do the ditto same thing in the put call also, so that I can regenerate the hash. Then only I'll be able to validate if this hash is exactly same as this hash. So I have to follow the same pattern, right? What I will do, find by ID with lean method. If doesn't exist, throw the error, then rest of the data from the task, then I'll generate the hash, right? Now here comes the difference. So const hash from header, right? What header? Request dot header. You remember the header name? It was if match, right? So we will read this header. That means when we are sending update task, we have the body, and in header what we will do, we will send this if match, right? So if I remove this one, if you see, if I just type if, right, I'm getting some auto suggestion from Postman. Why? Because these are HTTP standard headers, right? So I'll say if match, and I'll send the header, send this header, this hash value, right? So now what I'm doing, I'm reading it here simply, hash from header, request.header, if match, right? Then see, if it doesn't exist, right? If not hash from header, what I can do, I can immediately throw error, right? So I'll just copy it, because you don't want see me keep on typing this big error message, right? So if this header doesn't exist, that means this header is not sent from the client side 400. And of course, if you want, you can always change the error message, right? Missing if match header, the request must include the if match header to ensure data integrity during the update. So this will be the message that will be sent to the client, right? If you want, you can give other meaningful message, right? Just for demo, I'm giving this message, right? Then what I will do, I'll compare the two hash. Which hash? So if the hash that we generated again from the DB, right? If this doesn't match the hash from header, right? Throw error, right? So again, I'll copy paste some data, because no point in typing this, right? The same error message, right? Conflict version provided in the if header doesn't match the current version in the resource. Please reload the resource and try again, right? So I will save this one. If this is also not the case, then what we will do, we'll do the update, right? And on the update also I will add the lean method, right? So that we'll get the lean object, because when we do the update, this updated task will again have the version and the salt, right? So what I will do, I'll again remove it. So if anyways this fails, then we'll throw the error. Then I will say const, right, underscore v, then salt, then updated rest of data equals to updated task, right? Now there is one problem. This v and salt has been already declared somewhere here, right? So it is giving error. So what I will do, anyways I'm not going to use this one, so I'll say new version, just renaming it, right, so that it will not throw error. Anyways I'm not going to use this anymore, so new salt, just I'm trying to remove the unnecessary data, right, and updated rest of the data. So this updated rest of the data, I will send it to the request, right? So now we will do one round of testing if everything is working. So what I will do, I'll do a refresh and I'll delete all the data, right? So delete all the document, right? So I'll do a refresh. We'll start from the clean slate, right? So I'll bring the postman and I will send a fresh data, right? So now if you see, we got a new version, right? Now what I will do, I'll do a get call, right? So I'll send the request. Okay, so I'll get the information. What information is missing here? Not missing here, but not visible. I have to go to header and I have to use the e tag, right? I have the e tag here. So what I will do, let me quickly do the setting for the update, right? So update, what this will take? This will take the params, this new ID, right? So I'll update this one, right? Then what else we have to send? We have to send the updated data, the data that we actually want to update, right? And we don't have to send the version anymore, right? So I will load this data. That means this is the data that client has loaded from the get call, and now they will do some update and they will send the data, right? Now what else we have to update? We have to get the e tag. Okay, so I will copy this one and I'll go to header if match. Okay, I will paste it here, and the same thing I'll do here also, right? Great. Now the first person, what he is doing is completing it to JavaScript, right? So he will send the request and we don't get any data, right? Why is that? Why is that? Because here I'm not spreading it, right? So I should spread this one, right? So I'll do a fresh get call, right? Why? Because I updated the data, right? So now it has a different hash, right? So I'll use this hash now to send the information, right? So I'll update it. Now you can assume that this is from where our example has started, right? Great. So if I do the get the body, now it has the JavaScript, right? So I'll use this as our new example, right? So I'll come to body. Let us see if we get any more error. We'll start again from scratch, right? So body, I will update it here, right? And let me also check if the header is proper, right? So 8df5, right? So I'll come here, it has 8df5 and this guy also has 8df5, right? Now both of them have the latest information, right? So now this guy is trying to update it to TypeScript, right? So this guy will send the request, right? And it has been updated to TypeScript. Great. Now this guy, what he is doing, he doesn't have the latest information. So what he is trying to do, he's trying to do mark it as completed, right? Great. Now he doesn't have the latest information, right? So we will send the request, and what this is saying, message conflict, the version provided in the if match header doesn't match the content, right? So this guy cannot update, right? Now what I will do, I'll send the request again. Okay, I'll take the body, I'll show you the other example of doing false update, right? So now this guy has TypeScript and this guy also has TypeScript, right? Now I'll come to header and I'll copy the new header, right? The new e tag, right? And I will paste it here, right? And I will also paste it here, right? Great. Now this guy is doing a false update, right? So now if you see header is b68 something, right? Now this guy is doing false update, right? It updated again, right? Now if I do the get call, if you see B682, right? If I send this again, did the hash change? No, right? It's again that B682. Let me do another update. It is doing put request, put call, right? But since the data is not updated, I will generate the same hash. That is the advantage now. Now the other person, if he wants to save something, okay, because data has not changed, right? So he still has the latest information, right? So if he want, he can change something, right? This guy's false update is not going to matter now, right? He is able to update, right, to react, right? So problem solved, right? I think I'm satisfied with this solution. If you still think there is a potential security concern, feel free to put it in the comment box, right? But now I think this is a robust solution. Of course, this comes with what? Performance cost, right? Because what we are doing, we are generating hash, right? We are generating salt, right? This comes with performance, right? Not too much, but again, that depends on what scale you are doing, right? So this is a secure solution. Some of them are less secure, but extremely performant, right? Some of them are more secure, but there is a performance cost, right? End of the day, you have to decide what solution you have to pick based on your business need and based on the target audience, right? So now this hash solution will work. People cannot guess it because it is hash with a random salt that is stored in the database, right? And even with false update, it doesn't have any harm, right? Because if no data is changed, we are using the same hash again. It will of course regenerate the same hash, right? Because we are using the data, right? Now we have minor control. So even if I add a full stop, the hash will change, right? So other person cannot update it, right? So now we are able to check it at extremely granular level, right? This is a robust solution, I think, and I'll keep this video, I'll conclude this video here, right? And do tell me if you find this video interesting. Do subscribe to the channel because I will keep bringing more and more such kind of video. Give this a video thumbs up if you like this one, so that YouTube will send it to more and more number of people, and I'll see you in the next video.